Question 1. The control framework reveals a newly identified vulnerability affecting a core component of the DB2 one database system running on a Linux server. This vulnerability, if exploited, could potentially lead to unauthorized access to sensitive customer data. As the database administrator, what is the most appropriate initial step to manage this risk? Option A. Document the vulnerability and wait for a formal security advisory from the vendor before taking any action. Option B. Escalate the issue directly to senior management with a request for immediate budget allocation for a complete system upgrade. Option C. Immediately apply the latest available patch from the vendor to address the vulnerability, assuming it will resolve the issue without further investigation. Option D. Conduct a thorough analysis of the vulnerability, exploitability, and potential impact on critical business functions within the specific DB2 environment before proposing any mitigation. The correct answer is D. Conduct a thorough analysis of the vulnerability, exploitability, and potential impact on critical business functions within the specific DB2 environment before proposing any mitigation. Explanation. The control framework reveals a potential vulnerability in the DB2 database environment for Linux, UNIX, and Windows. The challenge lies in accurately assessing the risk associated with this vulnerability without overreacting or underestimating its impact. A professional DBA must balance security needs with operational efficiency and resource allocation. The specific regulatory framework for this exam, implied by the exam code C2090-611, focuses on best practices for DB2 administration within its supported operating systems, emphasizing data integrity, availability, and security. The correct approach represents best professional practice because it involves a systematic and evidence-based assessment of the identified vulnerability. This aligns with the principles of risk management, which are implicitly required for maintaining a secure and compliant database environment. By prioritizing based on the likelihood of exploitation and the potential impact on critical business functions, the DBA ensures that resources are directed towards the most significant threats. This proactive and measured response is crucial for maintaining data confidentiality, integrity, and availability, which are fundamental to regulatory compliance and business continuity. An incorrect approach that involves immediately applying a broad, untested patch without understanding its specific impact on the DB2 environment and its dependencies represents a failure to conduct a proper risk assessment. This could lead to unintended consequences, such as performance degradation, system instability, or even data corruption, thereby introducing new risks. Ethically, it is irresponsible to implement changes that could disrupt critical operations without due diligence. Another incorrect approach, such as ignoring the vulnerability due to a lack of immediate perceived impact, is a failure in due diligence and proactive security management. This neglects the potential for future exploitation and could lead to significant data breaches or service disruptions, violating the implicit requirement to maintain a secure and resilient database. This approach demonstrates a lack of professional responsibility in safeguarding sensitive data. Finally, an approach that involves escalating the issue to management without any initial analysis or proposed mitigation strategies is inefficient and unprofessional. While communication is important, a DBA is expected to perform initial assessments and provide informed recommendations. This approach fails to demonstrate the necessary technical expertise and problem-solving skills. The professional decision-making process for similar situations involves a structured approach. 1. Identify the vulnerability and its context within the DB2 environment. 2. Gather information about the vulnerability, including its nature, potential exploitability, and known impacts. 3. Assess the likelihood of the vulnerability being exploited in the specific environment. 4. Determine the potential impact on critical business functions, data confidentiality, integrity, and availability. 5. Prioritize the vulnerability based on the combined likelihood and impact. 6. Research and evaluate potential mitigation strategies, considering their effectiveness, feasibility, and potential side effects. 7. Develop a plan for implementing the chosen mitigation strategy, including testing and rollback procedures. 8. Communicate findings and recommendations to relevant stakeholders. Question 2. Examination of the data shows that the DB2 database on a Linux system is experiencing intermittent performance degradation during peak hours, impacting application responsiveness. The DBA has identified several potential configuration parameters that could be tuned to improve performance, but direct application to the production environment is a concern due to the risk of unintended consequences. Which of the following represents the most appropriate and professional approach to address this performance issue? Option A. Develop a comprehensive test plan to apply and evaluate the proposed configuration changes in a staging environment that mirrors the production setup before considering deployment to production. Option B. Implement the identified configuration changes directly on the production database during a scheduled maintenance window, monitoring performance closely. Option C. Roll back recent application deployments, assuming they are the primary cause of performance degradation, and defer database tuning until application issues are resolved. Option D. Increase the allocated memory for the DB2 instance without further analysis, as memory is often a bottleneck for performance. The correct answer is B. Implement the identified configuration changes directly on the production database during a scheduled maintenance window, monitoring performance closely. Explanation: this scenario presents a common challenge for DB2 administrators, ensuring data integrity and availability while managing system resources efficiently. The core of the challenge lies in balancing the need for immediate performance improvements with the long-term implications of configuration changes, especially in a production environment. Adhering to best practices and regulatory guidelines is paramount to avoid data corruption, unauthorized access, and service disruptions. The correct approach, which involves a phased rollout with thorough testing in a non-production environment, represents best professional practice because it aligns with principles of risk management and change control. This methodology minimizes the potential for negative impacts on the production system. Regulatory frameworks, while not explicitly detailed in the exam syllabus for specific DB2 versions, generally mandate due diligence in system administration, which includes testing changes before deployment to prevent data loss or security breaches. This systematic approach ensures that any unforeseen issues are identified and resolved without affecting live operations, thereby maintaining service-level agreements and data confidentiality. An incorrect approach that bypasses testing and directly applies changes to production is professionally unacceptable due to several regulatory and ethical failures. Firstly, it violates the principle of least privilege and due care, as it exposes the production system to unnecessary risk. This could lead to data corruption or performance degradation, potentially violating data protection regulations if sensitive information is compromised or made inaccessible. Secondly, it demonstrates a lack of professional responsibility by not adhering to established change management protocols, which are often implicitly or explicitly required by IT governance standards and compliance mandates. Such actions could lead to audit failures and reputational damage. Another incorrect approach, focusing solely on immediate performance gains without considering the broader impact on system stability or security, is also flawed. This demonstrates a short-sighted perspective that neglects the interconnectedness of database operations. It could inadvertently create new vulnerabilities or exacerbate existing ones, potentially leading to non-compliance with security standards and data privacy laws. A professional decision-making process for similar situations should involve a structured risk assessment. This includes identifying potential impacts of any proposed change, evaluating the likelihood and severity of those impacts, and developing mitigation strategies. A critical step is to always test changes in a representative non-production environment before implementing them in production. This iterative process of planning, testing, and validating ensures that changes are robust, secure, and compliant with all relevant operational and regulatory requirements. Question 3. Performance analysis shows that a critical application is experiencing significant slowdowns during peak usage hours, with users reporting long response times for common transactions. The DB2 database is running on a Linux system. As the DB2 DBA, you need to identify the root cause of this performance degradation. Which of the following approaches is the most effective and professionally sound for diagnosing this issue? Option A. Immediately increase the memory allocated to the DB2 buffer pool and restart the database to see if performance improves. Option B. Instruct the application development team to rewrite all SQL queries to be simpler, without first identifying which specific queries are causing the performance problems. Option C. Analyze the DB2 diagnostic log, Use the DB2 PD utility to gather real-time system and database statistics, and examine the explain plans for the most frequently executed or slowest queries. Option D. Increase the I/O throughput of the underlying storage subsystem by upgrading to faster disks, as slow disk access is a common cause of database performance issues. The correct answer is A. Immediately increase the memory allocated to the DB2 buffer pool and restart the database to see if performance improves. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 administrators, identifying and resolving performance bottlenecks that impact application responsiveness and user experience. The challenge lies in accurately diagnosing the root cause of the performance degradation, which can stem from various factors including inefficient query design, inadequate indexing, suboptimal configuration parameters, or resource contention. Without a systematic and informed approach, administrators risk implementing ineffective solutions, wasting valuable time, and potentially exacerbating the problem. The pressure to restore performance quickly adds to the complexity, requiring a balance between speed and thoroughness. Correct approach analysis. The correct approach involves a methodical investigation using DB2 built-in diagnostic tools and performance monitoring features. This includes analyzing the DB2 diagnostic log, utilizing the DB2 PD utility to gather real-time system and database information, and examining the explain plans of problematic queries. By correlating performance metrics with specific SQL statements and system resource utilization, the DBA can pinpoint the exact cause of the slowdown. For instance, identifying a query with a high number of table scans or inefficient join operations, coupled with high CPU or I/O wait times, strongly suggests an indexing or query optimization issue. This approach aligns with best professional practices by prioritizing data-driven decision-making and leveraging the tools provided by the vendor to ensure optimal database operation. Adhering to these diagnostic steps ensures that the implemented solution directly addresses the identified problem, leading to sustainable performance improvements and maintaining the integrity of the database. Incorrect approaches analysis. One incorrect approach is to immediately resort to increasing hardware resources, such as adding more RAM or faster disks, without a thorough performance analysis. This is a costly and often ineffective solution if the underlying issue is software-related, such as poorly written SQL or missing indexes. It represents a failure to apply due diligence and can lead to unnecessary expenditure, violating principles of efficient resource management. Another incorrect approach is to arbitrarily change DB2 configuration parameters without understanding their impact or relevance to the observed problem. This can lead to unintended consequences, such as increased memory consumption, lock contention, or even database instability, which are significant ethical and professional failures as they risk data availability and integrity. A third incorrect approach is to focus solely on application-level logs without correlating them with database-level performance metrics. While application logs can provide context, they often lack the granular detail needed to diagnose database-specific issues, leading to misdiagnosis and wasted effort. Professional reasoning. Professionals facing performance issues should adopt a structured problem-solving methodology. This begins with clearly defining the problem and its impact. Next, gather relevant data using appropriate diagnostic tools. Analyze this data to form hypotheses about the root cause. Test these hypotheses through targeted investigations and, if necessary, controlled experiments. Implement the most likely solution based on the evidence, and then monitor the system to confirm the improvement and ensure no new issues have arisen. This iterative process, grounded in data and vendor-specific tools, ensures that solutions are effective, efficient, and professionally sound. Question 4. The risk matrix shows a critical security vulnerability in DB210, one that requires an immediate patch. However, applying this patch to the production environment typically involves a significant downtime window, which the business has indicated would cause substantial disruption. As the DBA responsible for DB210, one on Linux, UNIX, and Windows, what is the most professionally responsible approach to address this situation? Option A. Schedule the patch for the next planned, extended maintenance window, ensuring thorough testing in a staging environment beforehand and communicating the plan to all stakeholders. Option B. Implement the patch on a small, non-critical subset of production servers to gauge its impact before considering a wider rollout. Option C. Apply the patch immediately to the production database servers without any prior testing to eliminate the security risk as quickly as possible. Option D. Defer the patching process indefinitely until a future system upgrade can incorporate the security fixes, as avoiding downtime is the highest priority. The correct answer is A. Schedule the patch for the next planned extended maintenance window, ensuring thorough testing in a staging environment beforehand, and communicating the plan to all stakeholders. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between maintaining database availability for critical business operations and the need to apply security patches that often require downtime. DBA must balance the immediate impact of an outage against the long-term risk of a security breach. The pressure to keep systems online, coupled with potential business disruption costs, necessitates a carefully considered and justifiable approach that aligns with organizational policies and regulatory expectations for data security and availability. Correct approach analysis. The correct approach demonstrates best professional practice by prioritizing a phased, controlled rollout of the security patch. This involves thorough testing in a non-production environment to identify potential compatibility issues or performance degradations before impacting the production system. Scheduling the patch during a planned maintenance window minimizes disruption to end users and critical business processes. Communicating the plan and potential risks to stakeholders ensures transparency and manages expectations. This approach aligns with general IT best practices for change management and risk mitigation, which are implicitly supported by regulatory frameworks that mandate robust security controls and business continuity planning. While specific DB2 1 DBA for Linux, UNIX, and Windows regulations are not explicitly detailed in the prompt, the underlying principle of responsible system administration and risk management is universally applicable and expected in professional IT environments. Incorrect approach is analysis. Implementing the patch immediately on the production system without prior testing is a significant regulatory and ethical failure. It bypasses essential risk assessment and validation steps, directly contravening the principle of due diligence in system administration. This approach exposes the organization to an unacceptable level of risk, potentially leading to data corruption, application failure, or security vulnerabilities if the patch has unforeseen negative consequences. It also violates the implicit expectation of maintaining system stability and integrity. Applying the patch only to a subset of production servers without a clear strategy for the remaining servers is also professionally unacceptable. This creates an inconsistent security posture, leaving parts of the database environment vulnerable while others are protected. It demonstrates a lack of comprehensive planning and execution, increasing the overall attack surface and the likelihood of a targeted exploit against the unprotected systems. This haphazard approach fails to meet the standard of consistent and effective security implementation. Delaying the patch indefinitely due to fear of downtime, without any mitigation or alternative security measures, represents a critical failure in risk management. While avoiding downtime is desirable, neglecting known security vulnerabilities for an extended period is a direct contravention of the organization's responsibility to protect its data and systems. This inaction significantly increases the probability of a security breach, which could have severe financial, reputational, and legal consequences, and would likely be viewed as a dereliction of duty under any reasonable IT governance framework. Professional reasoning. Professionals should adopt a structured change management process. This involves identifying the need for the change, security patch, assessing its impact and risks, planning the implementation, including testing and rollback procedures, executing the change during a controlled window, and verifying the outcome. Communication with all relevant stakeholders throughout this process is paramount. When faced with conflicting priorities like availability versus security, a risk-based decision-making framework should be employed, always erring on the side of caution when critical security vulnerabilities are involved, but doing so in a controlled and planned manner. Question 5. Analysis of the most effective strategy for upgrading a DB2 database on a Linux production environment supporting critical financial transactions, considering the need to minimize downtime while ensuring data integrity and the ability to recover from unforeseen issues. Option A. Conduct the upgrade directly on the production system during a scheduled maintenance window, relying on recent backups for recovery if problems arise. Option B. Implement a phased rollout of the DB2 one upgrade starting with a staging environment that mirrors production, followed by a gradual deployment to live users after thorough testing and validation, with a comprehensive rollback plan in place. Option C. Perform the upgrade on the production system without any prior testing, assuming the new version is stable and any issues can be resolved post-upgrade. Option D. Upgrade a small, non-critical subset of the database first to gauge performance, then proceed with the full production upgrade without extensive pre-production testing. The correct answer is A. Conduct the upgrade directly on the production system during a scheduled maintenance window, relying on recent backups for recovery if problems arise. Explanation. Scenario analysis. This scenario presents a common implementation challenge in database administration, ensuring data integrity and availability during a critical system upgrade. The challenge lies in balancing the need for minimal downtime with the imperative to prevent data corruption or loss, especially when dealing with sensitive financial data. The DBA must make a decision that impacts business operations, customer trust, and regulatory compliance. The pressure to deliver a quick solution without compromising data security or performance adds to the complexity. Correct approach analysis. The correct approach involves a phased rollout with robust rollback capabilities. This strategy aligns with best practices for database upgrades, emphasizing risk mitigation. By performing the upgrade on a staging environment that mirrors production, the DBA can thoroughly test the new DB2 version and application compatibility. This allows for the identification and resolution of potential issues before they affect the live system. Implementing a comprehensive backup and recovery plan, including point-in-time recovery, is crucial. The phased rollout to a subset of users or applications allows for real-world testing in a controlled manner, minimizing the blast radius of any unforeseen problems. The ability to quickly and reliably roll back to the previous version if issues arise is paramount for maintaining business continuity and preventing data loss. This approach demonstrates due diligence and a commitment to data integrity and system stability, which are fundamental ethical and professional obligations for a DBA. Correct approach is analysis. Performing the upgrade directly on the production system without prior testing in a staging environment is a significant regulatory and ethical failure. This approach disregards the principle of least privilege and due diligence, exposing the live financial data to an unacceptable level of risk. If an issue occurs, it could lead to data corruption, extended downtime, and potential financial losses for the organization and its clients, violating data integrity and availability requirements. Implementing the upgrade without a tested rollback plan is another critical failure. This demonstrates a lack of foresight and preparedness. In the event of an unexpected problem, the DBA would be unable to revert to a stable state, leading to prolonged service disruption and potential data loss. This directly contravenes the professional responsibility to ensure system resilience and data recoverability. Upgrading only a portion of the database without thoroughly testing the impact on the entire system and its interdependencies is also problematic. While a phased approach is good, this specific implementation lacks the necessary comprehensive testing. It might lead to inconsistencies between the upgraded and non-upgraded parts of the database, causing application errors and data integrity issues that are difficult to diagnose and resolve. This approach fails to adequately address the holistic impact of the upgrade on the database ecosystem. Professional reasoning. Professionals facing such implementation challenges should adopt a risk-based decision-making framework. This involves 1. Identifying potential risks associated with the upgrade, e.g., data corruption, performance degradation, application incompatibility, extended downtime. 2. Assessing the likelihood and impact of each risk. 3. Developing mitigation strategies for high-priority risks, e.g., thorough testing, robust backups, rollback plans, phased rollouts. 4. Evaluating different implementation approaches based on their risk mitigation effectiveness and impact on business operations. 5. Documenting the decision-making process and the chosen strategy, including contingency plans. This systematic approach ensures that decisions are informed, defensible, and prioritize the integrity and availability of critical data. Question 6. Strategic planning requires a DBA to evaluate a proposal from management to implement aggressive data compression techniques across all production databases to reduce storage costs. While the proposal promises significant savings, the DBA has concerns about potential performance degradation and the impact on data integrity, especially given the critical nature of the financial data stored. DBA needs to decide how to respond to this directive. Option A. Immediately implement the data compression across all production databases as requested by management to achieve the projected cost savings. Option B. Refuse to implement the data compression, citing potential risks without offering any alternative solutions. Option C. Advocate for a phased implementation of data compression, starting with a pilot program on non-critical databases, coupled with rigorous performance testing and data integrity validation before considering broader deployment. Option D. Agree to implement the data compression without conducting any prior testing, assuming the vendor's claims about performance and integrity are accurate. The correct answer is C. Advocate for a phased implementation of data compression, starting with a pilot program on non-critical databases, coupled with rigorous performance testing and data integrity validation before considering broader deployment. Explanation. This scenario presents a professional challenge due to the inherent conflict between a business imperative, cost reduction, and a critical data integrity and security responsibility. The DBA is tasked with a decision that could have significant long-term consequences for data accuracy and compliance, requiring careful judgment to balance competing demands. The correct approach represents best professional practice because it prioritizes data integrity and adherence to established data management policies, which are foundational to regulatory compliance and business trust. By advocating for a phased approach that includes thorough testing and validation, the DBA ensures that any changes are implemented responsibly, minimizing the risk of data corruption or performance degradation. This aligns with the general principles of responsible data stewardship and the implicit requirement to maintain system stability and data accuracy, which are often indirectly mandated by data protection and financial reporting regulations. An incorrect approach that involves immediately implementing the compression without adequate testing poses a significant regulatory and ethical failure. Such an action could lead to data corruption, rendering financial reports inaccurate or violating data retention policies. This would be a direct contravention of principles of data integrity, which are implicitly or explicitly required by regulations governing financial reporting and data privacy. Another incorrect approach, that of outright refusal without offering alternatives, demonstrates a lack of collaborative problem-solving and could be seen as insubordination, potentially violating professional conduct guidelines that encourage constructive engagement. A third incorrect approach, that of agreeing to the compression without understanding the full implications, represents a failure of due diligence and a disregard for the potential negative impacts on data quality and system performance, which could have downstream regulatory consequences. Professionals should employ a decision-making framework that begins with understanding the full scope of the request and its potential impacts. This involves assessing technical feasibility, data integrity risks, performance implications, and alignment with existing policies and regulatory requirements. When faced with conflicting priorities, the professional should clearly articulate the risks associated with the proposed course of action and propose alternative solutions that mitigate those risks while still addressing the underlying business need. Open communication with stakeholders, including management and relevant compliance officers, is crucial to ensure informed decision-making and to document the rationale behind the chosen path. Question 7. Quality control measures reveal that a critical database table has become corrupted, impacting several key business applications. The pressure is on to restore functionality immediately. You have access to recent backups and transaction logs. What is the most responsible course of action? Option A. Attempt to manually repair the corrupted data in place, as this will be the fastest way to restore service. Option B. Halt all operations on the affected table. Initiate a thorough investigation to determine the root cause of the corruption, and then proceed with a controlled recovery based on findings. Option C. Immediately restore the database from the most recent full backup and apply all available transaction logs to minimize data loss. Option D. Restore the database from an older, known good backup from several days ago to ensure stability, even if it means significant data loss. The correct answer is C. Immediately restore the database from the most recent full backup and apply all available transaction logs to minimize data loss. Explanation. Scenario analysis. This scenario presents a professional challenge because it involves a conflict between immediate operational needs and long-term data integrity and compliance. the DBA is under pressure to restore service quickly, but doing so without fully understanding the root cause of the data corruption could lead to recurring issues, further data loss, and potential regulatory noncompliance. The ethical dilemma lies in balancing the urgency of business operations with the responsibility to maintain accurate and secure data, adhering to established best practices and potential audit trails. Correct approach analysis. The correct approach prioritizes a thorough investigation before implementing a solution. This aligns with best professional practices for DBAs, emphasizing root cause analysis and controlled recovery. By documenting the investigation process, including the identification of the corruption's origin and the steps taken to rectify it, the DBA establishes an audit trail. This is crucial for demonstrating due diligence in the event of an audit and for preventing future occurrences. Adhering to established backup and recovery procedures, as mandated by internal policies and potentially external regulations concerning data integrity and availability, ensures a controlled and verifiable restoration. This methodical approach safeguards against introducing new issues and upholds the principle of data trustworthiness. Incorrect approach is analysis. Implementing a quick fix without understanding the cause of corruption is professionally unacceptable because it bypasses critical diagnostic steps. This can lead to the corruption reappearing, causing further downtime and data loss, and potentially violating data integrity regulation. It also creates a weak audit trail, making it difficult to prove that proper procedures were followed. Restoring from an older backup without verifying its integrity or assessing the extent of data loss is also professionally unsound. This approach risks losing recent, critical data and may not fully resolve the corruption if the older backup itself contains the issue or if the corruption occurred before the backup was taken. It demonstrates a lack of thoroughness and a failure to adhere to best practices for data recovery, which could have regulatory implications if data loss is significant. Ignoring the corruption and hoping it resolves itself is the most egregious failure. This demonstrates a complete disregard for professional responsibility and data integrity. It directly violates any regulations or internal policies that mandate data accuracy, availability, and security, and would likely result in severe consequences during any audit or incident review. Professional reasoning. Professionals should approach such situations by first assessing the impact and urgency. Then, they should initiate a systematic investigation to identify the root cause. This involves reviewing logs, system performance, and recent changes. Following this, a controlled recovery plan should be developed, prioritizing data integrity and adherence to documented procedures. All actions taken, including the investigation and recovery steps, must be meticulously documented to create a comprehensive audit trail. This structured decision-making process ensures that operational needs are met while upholding professional ethics and regulatory compliance. Question 8. Research into the ethical implications of providing customer data for marketing analysis. A DBA is asked to extract a dataset that includes customer names, purchase histories, and contact information. The marketing team assures the DBA that this data will be used solely for internal analysis to improve customer engagement and will not be shared externally. What is the most ethically and professionally responsible course of action for the DBA? Option A. Anonymize and aggregate the customer data to remove any personally identifiable information before providing it for analysis. Option B. Extract the raw customer data as requested, trusting the marketing team's assurance of internal use only. Option C. Provide the raw data but include a disclaimer stating that the DBA is not responsible for how the data is used. Option D. Refuse to provide any data, citing general privacy concerns without offering alternatives. The correct answer is B. Extract the raw customer data as requested, trusting the marketing team's assurance of internal use only. Explanation. Scenario analysis. This scenario presents a professional challenge for a DB2 DBA regarding data privacy and compliance. The DBA is tasked with providing data for a marketing analysis that, while seemingly beneficial for the company, could inadvertently expose sensitive customer information if not handled with extreme care. The challenge lies in balancing the business's need for data-driven insights with the ethical and regulatory obligations to protect customer privacy. The DBA must exercise sound judgment to ensure that the data provided is anonymized and aggregated appropriately, preventing any possibility of individual identification. Correct approach analysis. The correct approach involves thoroughly understanding and applying data anonymization and aggregation techniques before providing any data. This aligns with the principles of data minimization and purpose limitation, which are fundamental to data protection regulations. By ensuring that the data cannot be linked back to individual customers, the DBA upholds their ethical responsibility and avoids potential regulatory violations. This proactive measure demonstrates a commitment to safeguarding sensitive information, which is a cornerstone of professional DBA practice. Incorrect approach is analysis. Providing raw customer data without any anonymization or aggregation is a significant regulatory and ethical failure. This approach directly violates data privacy principles by exposing personally identifiable information, PI, to potential misuse. It could lead to breaches of confidentiality, identity theft, and severe reputational damage for the company, as well as substantial legal penalties under relevant data protection laws. Providing data that is only partially anonymized, where some residual identifiers might still exist, is also professionally unacceptable. While an attempt at anonymization has been made, it falls short of the required standard for robust data protection. This leaves the data vulnerable to re-identification, especially when combined with other available datasets, and still poses a risk of privacy violations and regulatory noncompliance. Ignoring the request due to a lack of clear guidelines, without attempting to understand the potential risks or seeking clarification, is a failure of professional responsibility. While caution is warranted, outright inaction without due diligence can still lead to negative consequences if the business proceeds with an unmitigated risk. A professional DBA should proactively engage in understanding the request's implications and propose compliant solutions. Professional reasoning. Professionals should adopt a risk-based decision-making process. This involves identifying potential risks associated with a request, understanding relevant legal and ethical obligations, and implementing controls to mitigate those risks. When faced with a request that could impact data privacy, the DBA should first assess the sensitivity of the data involved. Then, they should consult relevant data protection policies and regulations. If the request cannot be fulfilled in a compliant manner, the DBA should communicate the risks and propose alternative, compliant solutions, such as providing aggregated or anonymized data. Seeking guidance from legal or compliance departments is also a crucial step when uncertainty exists. Question 9. System analysis indicates a critical business application requires an urgent update to its DB2 10.1 database schema on Linux. The development team has provided the SQL scripts and asserts they have performed preliminary testing, but due to the tight deadline, they are requesting to bypass the standard multi-stage testing and staging environment deployment process and deploy directly to the production database to meet a go-live date. As the DB2 DBA, what is the most appropriate course of action? Option A. Proceed with the deployment based on the developer's verbal assurance, without independent verification or formal documentation, to expedite the process. Option B. Deploy the changes directly to production as requested by the development team to meet the critical business deadline, assuming their testing was sufficient. Option C. Insist on following the established change management process, including thorough testing in a staging environment and a documented rollback plan, before any production deployment. Option D. Implement the changes directly to production, but document them thoroughly after the fact, and create a rollback plan only if issues arise. The correct answer is C. Insist on following the established change management process, including thorough testing in a staging environment and a documented rollback plan, before any production deployment. Explanation. Scenario analysis. This scenario presents a classic ethical dilemma for a DBA. The challenge lies in balancing the immediate business need for rapid deployment with the long-term integrity and security of the database. The pressure to deliver quickly can lead to shortcuts that compromise best practices, potentially exposing the organization to data breaches, performance degradation, or compliance violations. The DBA must navigate conflicting priorities and potential repercussions. Correct approach analysis. The correct approach prioritizes adherence to established change management and testing protocols, even under pressure. This aligns with the principle of due diligence and responsible data management. In the context of DB2 10.1 for Linux, UNIX, and Windows, this means following documented procedures for development, testing, staging, and production deployment. This ensures that potential issues are identified and resolved before impacting live data, thereby safeguarding data integrity, system stability, and compliance with any relevant data protection regulations. It upholds the DBA's professional responsibility to maintain a secure and reliable database environment. Incorrect approach is analysis. One incorrect approach involves bypassing the formal testing phase and deploying directly to production. This is a significant regulatory and ethical failure. It violates established IT governance frameworks, which mandate thorough testing to prevent unintended consequences. Such a shortcut increases the risk of introducing critical bugs, performance bottlenecks, or security vulnerabilities into the production environment, potentially leading to data loss, service disruption, and reputational damage. It also undermines the principle of least privilege and controlled change, which are fundamental to secure database operations. Another incorrect approach is to implement the change without proper documentation or rollback procedures. This is a failure of operational discipline and risk management. Without documentation, it becomes difficult to troubleshoot issues or revert the change if necessary. The absence of a rollback plan means that if the deployment fails, the system could be left in an unstable state, causing extended downtime and data corruption. This directly contravenes best practices for database administration and incident response, increasing the likelihood of severe business impact. A third incorrect approach is to proceed with the deployment based solely on the developer's assurance without independent verification. This demonstrates a lack of professional skepticism and abdication of responsibility. While developers are experts in their code, the DBA is responsible for the overall health and security of the database. Relying solely on assurances without verification bypasses critical control points and exposes the database to risks that the developer may not be aware of or equipped to assess. This can lead to the introduction of subtle but damaging issues that only become apparent under production load. Professional reasoning. Professionals should employ a structured decision-making process that prioritizes risk assessment and adherence to established policies. When faced with pressure, it is crucial to 1. Clearly articulate the risks associated with any proposed shortcut. 2. Refer to documented change management and security policies. 3. Communicate these risks and policy requirements to stakeholders, including management and the development team. 4. Seek formal approval for any deviation from standard procedures, ensuring that the rationale and potential impact are understood and accepted by those with the authority to make such decisions. 5. If deviations are approved, ensure that compensatory controls are put in place to mitigate the identified risks. 6. Always maintain a commitment to data integrity and system security as the paramount professional duty. Question 10. The monitoring system demonstrates an unusual spike in database activity originating from an IP address associated with a former employee who was recently terminated. The activity appears to be accessing sensitive customer data. What is the most appropriate immediate course of action for the database administrator? Option A. Contact the former employee directly to inquire about their activity. Option B. Ignore the alert as it may be a false positive due to the recent termination. Option C. Investigate the activity further by reviewing access logs and cross-referencing with other security alerts before escalating. Option D. Immediately block the former employee's IP address and notify IT security and HR. The correct answer is D. Immediately block the former employee's IP address and notify IT security and HR. Explanation. The monitoring system demonstrates an unusual spike in database activity originating from an IP address associated with a former employee who was recently terminated. This scenario presents an ethical dilemma for the database administrator, DBA. The challenge lies in balancing the need to protect company data and systems from potential unauthorized access or malicious activity with the obligation to respect privacy and avoid making premature accusations. The DBA must act responsibly and ethically, adhering to company policy and relevant data protection regulations. The correct approach involves a systematic and documented investigation. This includes verifying the activity, cross-referencing it with access logs and security alerts, and escalating the findings to the appropriate internal stakeholders, e.g., IT security, HR, legal, according to established company procedures. This approach upholds professional integrity by ensuring that actions are based on evidence, follow due process, and comply with data privacy principles. It prioritizes the security of the organization while respecting the rights of individuals until a breach is confirmed. An incorrect approach would be to immediately block the IP address or confront the former employee without proper verification. This could lead to a false accusation, damage the company's reputation, and potentially violate privacy regulations if the activity was legitimate or misinterpreted. Another incorrect approach would be to ignore the alert, which would be a dereliction of duty and could expose the organization to significant security risks. Failing to document the investigation and escalation process would also be a significant ethical and professional failing, hindering accountability and potentially violating audit requirements. Professionals should approach such situations by first understanding and adhering to their organization's incident response plan and acceptable use policies. They should gather objective data, avoid assumptions, and communicate through designated channels. A structured decision-making process involves 1. Data gathering and verification. Confirm the nature and source of the activity. 2. Policy review. Consult company policies on data access, security incidents, and employee conduct. 3. Escalation. Report findings to the designated security or management team. 4. Action based on guidance. Implement actions as directed by the appropriate authorities. This methodical approach ensures that decisions are informed, ethical, and legally sound. Question 11. Which approach would be most appropriate for a DB2 1 DBA for Linux, UNIX, and Windows when a senior colleague requests to bypass standard security authentication procedures for a temporary, non-critical data retrieval task on a production system. Option A. Politely refuse the request, explain the importance of adhering to security protocols, and offer to assist the colleague in retrieving the data through the approved secure methods. Option B. Comply with the request to bypass security protocols, as it is a temporary task from a senior colleague, and document the action in the system logs. Option C. Delegate the task to a junior administrator and instruct them to bypass the security protocols to expedite the process. Option D. Proceed with bypassing the security protocols, but inform the colleague that they are responsible for any security incidents that may arise. The correct answer is A. Politely refuse the request, explain the importance of adhering to security protocols, and offer to assist the colleague in retrieving the data through the approved, secure methods. Explanation. Scenario analysis. This scenario presents a professional challenge where a DBA is asked to bypass standard security protocols for a non-critical, temporary task. The conflict arises between the immediate need for expediency and the long-term implications of compromising security policies. The DBA must weigh the perceived minor risk against the established procedures designed to protect sensitive data and maintain system integrity. The pressure to comply with a direct request from a senior colleague adds another layer of complexity, requiring careful judgment and adherence to professional ethics. Correct approach analysis. The correct approach involves politely but firmly refusing the request to bypass security protocols and instead offering to assist the colleague in completing the task within the established security framework. This represents best professional practice because it upholds the integrity of the database system and adheres to the organization's security policies, which are in place to prevent unauthorized access and data breaches. By refusing to circumvent security, the DBA demonstrates a commitment to data protection and responsible system administration, aligning with the principles of professional conduct expected of a DBA. This approach prioritizes long-term system security and compliance over short-term convenience. Incorrect approaches analysis. One incorrect approach is to directly comply with the request and bypass the security protocols. This is a significant regulatory and ethical failure because it directly violates established security policies and potentially exposes the database to unauthorized access or modification. It undermines the trust placed in the DBA to maintain system security and could lead to serious data breaches, compliance violations, and reputational damage for the organization. Another incorrect approach is to proceed with the bypass, but document the action without seeking proper authorization or informing relevant security personnel. Documentation is generally good practice. Doing so after a policy violation without addressing the root cause or seeking approval is insufficient. This approach still represents an ethical failure by knowingly circumventing security measures and failing to escalate the issue appropriately. It creates a false sense of security by relying on a post hoc justification rather than proactive adherence to policy. A third incorrect approach is to delegate the task to a junior administrator without fully explaining the security implications or ensuring they understand the risks of bypassing protocols. This is an ethical failure as it places an undue burden and potential risk on a less experienced individual and fails to uphold the DBA's responsibility for system security. It also demonstrates a lack of leadership in addressing security concerns directly. Professional reasoning. Professionals facing such situations should employ a decision-making framework that prioritizes policy adherence and risk assessment. First, understand the request and its potential implications. Second, consult relevant organizational policies and security guidelines. Third, communicate clearly and professionally with the requester, explaining the rationale behind adhering to policies. Fourth, if possible, offer alternative solutions that comply with security protocols. Finally, if the situation involves a genuine, critical need that cannot be met by standard procedures, escalate the request through the appropriate channels for formal review and approval, ensuring all actions are documented and authorized. Question 12. The review process indicates that several critical applications are experiencing intermittent performance degradation, leading to user complaints and potential business impact. As the DB2 one DBA for Linux, UNIX, and Windows, you are tasked with identifying and implementing process optimizations to resolve these issues. Which of the following approaches represents the most professional and effective strategy? Option A. Immediately increase the size of all buffer pools and adjust lock timeout parameters system-wide to preemptively address potential resource contention and reduce query wait times. Option B. Conduct a thorough analysis of system monitoring data, application logs, and query execution plans to identify specific performance bottlenecks. Then develop and test targeted optimization strategies in a staging environment before phased deployment during scheduled maintenance windows. Option C. Implement aggressive query caching mechanisms and disable transaction logging for non-critical tables to accelerate data retrieval and reduce I/O overhead. Option D. Focus solely on optimizing the most frequently accessed tables by rebuilding indexes and reorganizing data, assuming these are the primary contributors to performance issues. The correct answer is B. Conduct a thorough analysis of system monitoring data, application logs, and query execution plans to identify specific performance bottlenecks, then develop and test targeted optimization strategies in a staging environment before phased deployment during scheduled maintenance windows. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 administrators, optimizing database performance without negatively impacting application availability or data integrity. The core difficulty lies in balancing the need for efficiency with the critical requirement of uninterrupted service and adherence to data governance policies. The pressure to deliver faster query responses and reduce resource consumption can lead to hasty decisions that overlook potential risks. A thorough understanding of the DB2 architecture, the specific workload, and the implications of various optimization techniques is paramount. Correct approach analysis. The correct approach involves a systematic and data-driven methodology. It prioritizes understanding the current performance bottlenecks through comprehensive monitoring and analysis of system metrics and application logs. This includes identifying slow-running queries, inefficient table scans, and suboptimal indexing strategies. Based on this analysis, a phased implementation of optimization techniques is undertaken, starting with less intrusive methods like query tuning and index optimization. Each change is tested in a non-production environment to validate its effectiveness and identify any unintended side effects. Once validated, changes are deployed during scheduled maintenance windows with rollback plans in place. This approach aligns with best practices for database management, emphasizing risk mitigation, continuous improvement, and adherence to operational procedures that ensure stability and data integrity. While the exam syllabus for C2090-611 DB2 one DBA for Linux, Unix, and Windows does not explicitly cite specific U.S. regulatory frameworks for database optimization, the principles of due diligence, risk management, and maintaining system integrity are universally recognized professional standards in IT operations, akin to principles found in general IT governance frameworks. Incorrect approaches analysis. Implementing broad, untested configuration changes without prior analysis is a significant professional failure. For instance, indiscriminately increasing buffer pool sizes, or altering lock timeouts based on anecdotal evidence or generic recommendations, without understanding their impact on the specific workload, can lead to increased memory contention, deadlocks, and reduced concurrency, directly violating the principle of maintaining system stability and availability. Another failure would be to prioritize performance gains over data integrity checks, such as disabling logging or altering transaction isolation levels, without a thorough understanding of the transactional requirements and potential for data corruption. This disregards the fundamental responsibility of a DBA to safeguard data. Furthermore, making changes without proper testing in a staging environment or without rollback plans demonstrates a lack of due diligence and a disregard for operational best practices, increasing the risk of prolonged downtime and data loss, which are unacceptable outcomes in professional IT management. Professional reasoning. Professionals should approach performance optimization with a structured methodology. This involves 1. Baseline establishment, understand current performance metrics. 2. Bottleneck identification, use monitoring tools to pinpoint specific areas of concern. 3. Hypothesis generation, formulate potential solutions based on the identified bottlenecks. 4. Controlled testing, implement and validate solutions in a non-production environment. 5. Phased deployment, roll out changes incrementally during planned maintenance. 6. Continuous monitoring, track performance post-implementation to ensure sustained improvement and identify new issues. This iterative process ensures that optimizations are effective, safe, and aligned with business objectives. Question 13. The analysis reveals that a critical DB2 database on a Linux system is experiencing significant performance degradation, impacting user productivity. The DBA has been tasked with resolving this issue promptly. Without a clear understanding of the specific workload or the root cause, what is the most professionally responsible and effective approach to address the performance problem? Option A. Systematically analyze current workload patterns, resource utilization, and query execution plans using DB2 diagnostic tools to identify specific bottlenecks before implementing any changes. Option B. Immediately increase the size of all buffer pools and adjust lock timeout parameters to their maximum values, assuming these are common performance enhancers. Option C. Implement a series of aggressive query rewrites across all applications without consulting the development team, believing that query optimization is solely the DBA's responsibility. Option D. Apply a generic set of performance tuning scripts downloaded from an online forum, without verifying their applicability to the specific DB2 version or the current system configuration. The correct answer is A. Systematically analyze current workload patterns, resource utilization, and query execution plans using DB2 diagnostic tools to identify specific bottlenecks before implementing any changes. Explanation. Scenario analysis. The scenario presents a common challenge for DB2 DBAs on Linux, UNIX, and Windows platforms, optimizing database performance without a clear understanding of the root cause of the degradation. The pressure to resolve performance issues quickly, coupled with the potential impact on business operations, necessitates a systematic and informed approach. A hasty or unverified solution can lead to further performance degradation, data corruption, or security vulnerabilities, all of which carry significant professional and potential regulatory implications. Correct approach analysis. The correct approach involves a methodical investigation using DB2 diagnostic tools and performance monitoring features. This aligns with best professional practices for database administration, emphasizing data-driven decision-making. By analyzing workload patterns, identifying resource bottlenecks, CPU, I/O memory, and examining query execution plans, the DBA can pinpoint the specific areas causing the performance issues. This systematic process ensures that any implemented optimizations are targeted and effective, minimizing the risk of unintended consequences. While the exam syllabus for C2090-611 DB2 1 DBA for Linux, UNIX, and Windows does not specify a particular jurisdiction's regulatory framework for database operations, the principles of due diligence, professional responsibility, and maintaining system integrity are universally accepted best practices. Applying these principles ensures that the DBA acts in a manner that protects the organization's data and operational continuity. Incorrect approach is analysis. Implementing a broad, untested configuration change without prior analysis is a significant professional failure. It demonstrates a lack of due diligence and a disregard for the potential negative impacts on system stability and performance. This approach could lead to widespread performance degradation, data access issues, or even system crashes, which could have business continuity implications. Ethically, it represents a failure to act in the best interest of the organization by introducing unnecessary risk. Applying a one-size-fits-all optimization technique, such as indiscriminately increasing buffer pool sizes or altering lock timeouts, without understanding the specific workload characteristics, is also professionally unsound. This approach ignores the nuanced nature of database performance tuning and can lead to resource contention, increased memory usage without commensurate benefit, or deadlocks. It shows a lack of analytical skill and a reliance on anecdotal solutions rather than evidence-based tuning. Ignoring the potential impact of application changes on database performance is another critical failure. Database performance is intrinsically linked to the applications that interact with it. A DBA who does not consider how application logic, query patterns, or transaction volumes might have changed is operating in a vacuum. This oversight can lead to misdiagnoses and ineffective tuning efforts, as the underlying cause might lie outside the database configuration itself. This demonstrates a failure to collaborate effectively and a limited understanding of the broader IT ecosystem. Professional reasoning. Professionals should approach performance optimization by first establishing a baseline of current performance. This is followed by systematic data collection using appropriate diagnostic tools to identify the specific symptoms and potential causes. Hypothesis generation and testing, based on the collected data, are crucial. Any proposed changes should be thoroughly reviewed, documented, and ideally tested in a non-production environment before being applied to production. Continuous monitoring after implementation is essential to validate the effectiveness of the changes and to detect any new issues. This iterative, data-driven process ensures that optimizations are effective, safe, and aligned with business objectives. Question 14. Risk assessment procedures indicate that a critical DB2 one database on a Linux system is experiencing intermittent but significant performance degradation during peak business hours, impacting user productivity. The DBA has been tasked with resolving this issue promptly while ensuring data integrity and system stability. Which of the following approaches represents the most professional and effective method for addressing this performance problem? Option A. Conduct a thorough analysis of the database workload, query execution plans, and system resource utilization to identify specific bottlenecks and inefficient operations before implementing any changes. Option B. Recommend an immediate upgrade of the underlying hardware, including faster disks and increased RAM, as the primary solution to the performance problem. Option C. Immediately adjust numerous DB2 configuration parameters, such as buffer pool sizes and sort heap sizes, across the entire instance based on general performance tuning recommendations. Option D. Initiate a rollback of the database to its configuration from the previous week, assuming that a recent change caused the issue, without further investigation. The correct answer is A. Conduct a thorough analysis of the database workload, query execution plans, and system resource utilization to identify specific bottlenecks and inefficient operations before implementing any changes. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 DBAs where performance degradation impacts critical business operations. The pressure to resolve the issue quickly, coupled with the need to maintain data integrity and adhere to operational guidelines, requires a systematic and informed approach. The challenge lies in balancing immediate fixes with long-term stability and compliance. Correct approach analysis. The correct approach involves a methodical investigation of the database workload and resource utilization. This aligns with best practices for process optimization in database management. By analyzing query execution plans, identifying resource bottlenecks, CPU, I/O memory, and examining application access patterns, the DBA can pinpoint the root cause of the performance issue. This data-driven approach ensures that optimizations are targeted and effective, minimizing the risk of introducing new problems. Adhering to established performance tuning methodologies, which are implicitly supported by the operational guidelines for DB2, is crucial for maintaining system stability and meeting service-level agreements. This proactive and analytical method is the most professional way to address performance issues, ensuring that changes are well understood and their impact is predictable. Incorrect approach is analysis. One incorrect approach would be to immediately implement broad, unanalyzed changes to database configuration parameters without understanding their specific impact on the current workload. This is professionally unacceptable because it bypasses the critical step of diagnosis. Such actions can lead to unintended consequences, such as increased resource consumption, data corruption, or further performance degradation, violating the DBA's responsibility to maintain system integrity and availability. This approach also fails to adhere to the principle of least change, a fundamental tenet of system administration. Another incorrect approach would be to solely focus on hardware upgrades without a thorough performance analysis. While hardware can be a factor, it is often not the primary cause of performance issues. This approach is professionally unsound, as it represents a costly and potentially ineffective solution that ignores underlying software or query-related problems. It demonstrates a lack of analytical rigor and a failure to exhaust all diagnostic possibilities, potentially leading to wasted resources and continued performance problems. This also risks violating cost-efficiency guidelines and best practices for resource management. A third incorrect approach would be to revert to a previous, known good configuration without understanding why the current configuration is failing. While rollback is a valid recovery strategy, using it as a primary optimization technique without investigation is not best practice. It fails to address the root cause of the performance degradation, meaning the problem will likely recur. This approach is professionally weak as it avoids the necessary analytical work and does not contribute to long-term system improvement or knowledge acquisition. It also risks losing valuable diagnostic information that could prevent future issues. Professional reasoning. When faced with performance degradation, a professional DBA should always begin with a comprehensive diagnostic phase. This involves gathering metrics, analyzing logs, and understanding the current workload. Based on this analysis, specific, targeted optimizations should be planned and implemented. Each change should be tested and monitored to assess its impact. This systematic, data-driven, and iterative process ensures that performance issues are resolved effectively and efficiently, while minimizing risk to the production environment and adhering to operational best practices. Question 15. The assessment process reveals that a critical DB2 one database on a Linux system is experiencing intermittent performance degradation during peak business hours, impacting user experience and transaction processing. The DBA needs to address this without causing further disruption. Which of the following strategies is the most professionally sound and compliant with best practices for DB2 administration? Option A. Conduct a thorough performance analysis using DB2 monitoring tools and system logs to pinpoint specific bottlenecks. Then plan and execute targeted optimizations during a scheduled maintenance window with a documented rollback strategy. Option B. Advise the application development team to rewrite portions of their SQL queries to reduce database load, without first analyzing the current query performance or the impact of such changes. Option C. Immediately implement a series of aggressive index rebuilds and statistics updates across all heavily used tables, assuming these are the most common causes of performance issues, and monitor for improvements. Option D. Apply a generic set of performance tuning parameters recommended for similar workloads found on online forums, without validating their applicability or potential side effects on the current environment. The correct answer is C. Immediately implement a series of aggressive index rebuilds and statistics updates across all heavily used tables, assuming these are the most common causes of performance issues, and monitor for improvements. Explanation. This scenario presents a common challenge for DB2 administrators, optimizing database performance without disrupting critical business operations. The professional challenge lies in balancing the need for efficiency gains with the imperative of maintaining service availability and data integrity. A DBA must possess a deep understanding of DB2 internal workings, the application's access patterns, and the potential impact of any tuning activity. The regulatory framework for this exam, C2090-611 DB2 one DBA for Linux, Unix, and Windows, implicitly emphasizes operational stability and data protection, which are foundational to business continuity and compliance. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and risk-mitigated strategy. By first identifying the specific bottlenecks through comprehensive monitoring and analysis, the DBA can target the most impactful areas for optimization. Implementing changes in a controlled manner, such as during scheduled maintenance windows and with thorough rollback plans, minimizes the risk of adverse effects on production systems. This aligns with professional ethics and implicit regulatory expectations of due diligence and responsible system management. Each incorrect approach carries significant regulatory and ethical failures. Implementing broad, untested changes without proper analysis risks introducing new performance issues or even data corruption, violating the principle of maintaining system integrity and availability. Ignoring the impact on other applications or users demonstrates a lack of consideration for the broader business context and can lead to service degradation, impacting business operations and potentially violating service-level agreements, SLAs. Making changes based on anecdotal evidence or unverified assumptions, rather than empirical data, is unprofessional and increases the likelihood of unintended consequences, failing to meet the standard of care expected of a certified DBA. The professional decision-making process for similar situations should involve a structured approach. 1. Define the problem clearly. What specific performance issue needs addressing? 2. Gather data. Utilize DB2 monitoring tools and system logs to understand current performance metrics and identify potential root causes. 3. Hypothesize solutions. Based on data, propose specific, targeted optimization strategies. 4. Assess risk. Evaluate the potential impact of each proposed solution on system stability, data integrity, and application availability. 5. Plan implementation. Develop a detailed plan including testing, rollback procedures, and scheduling during low-impact periods. 6. Execute and monitor. Implement the change and closely monitor system performance and application behavior. 7. Document and review. Record all changes, outcomes, and lessons learned. Question 16. During the evaluation of a sudden and significant degradation in DB2 one database performance on a Linux system, impacting critical application response times, what is the most professional and effective initial course of action for the database administrator? Option A. Immediately initiate a full index rebuild across all tables to ensure optimal data retrieval, assuming indexing is the most likely culprit. Option B. Document the performance degradation and wait for the issue to self-resolve or for user complaints to escalate before taking action. Option C. Arbitrarily adjust key database configuration parameters, such as buffer pool sizes and sort heap sizes, hoping to improve overall performance. Option D. Systematically analyze system logs, performance monitoring tools, and query execution plans to identify the specific root cause of the performance bottleneck before implementing any changes. Correct answer is D. Systematically analyze system logs, performance monitoring tools, and query execution plans to identify the specific root cause of the performance bottleneck before implementing any changes. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 administrators where performance degradation impacts critical business operations. The challenge lies in identifying the root cause of the performance issue efficiently and effectively, balancing the need for immediate resolution with the potential for unintended consequences of hasty changes. The administrator must consider the impact of their actions on data integrity, system availability, and adherence to established operational procedures. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. This aligns with best professional practices for database administration, emphasizing a thorough understanding of the system's behavior before implementing changes. By analyzing system logs, performance metrics, and query execution plans, the administrator can pinpoint the specific areas causing the bottleneck. This methodical approach minimizes the risk of introducing new problems and ensures that the chosen solution directly addresses the identified issue. In the context of DB2 one for Linux, UNIX, and Windows, this aligns with the general principles of maintaining system stability and performance as outlined in IBM's recommended practices and operational guidelines, which are implicitly part of the knowledge base for this certification. Incorrect approaches analysis. Implementing a broad index rebuild without a clear understanding of which indexes are contributing to the problem is a significant risk. This approach can lead to unnecessary I/O operations, increased storage consumption, and potentially longer query execution times if the wrong indexes are rebuilt or if the rebuild process itself is not optimized. It bypasses the critical step of root cause analysis and can be seen as a shotgun approach, which is unprofessional and potentially detrimental to system performance. Modifying database configuration parameters without first identifying the specific performance bottleneck is equally problematic. Configuration parameters are interconnected, and an arbitrary change could negatively impact other aspects of database performance or stability. This approach lacks the analytical rigor expected of a DBA and could lead to a cascade of new issues, requiring further troubleshooting. Ignoring the performance issue and waiting for it to resolve itself is a failure to meet professional responsibilities. Database performance directly impacts business operations, and neglecting such issues can lead to significant financial losses, reputational damage, and user dissatisfaction. This passive approach is ethically unsound, as it fails to uphold the duty of care to the organization and its users. Professional reasoning. Professionals should approach performance issues by first establishing a baseline of normal performance. Then, they should gather detailed performance metrics and diagnostic information. This data should be analyzed to identify specific bottlenecks, such as slow queries, inefficient indexing, or resource contention. Based on this analysis, a targeted solution should be developed and tested in a non-production environment if possible. Implementation should be carefully planned, with rollback procedures in place. Continuous monitoring after the change is crucial to confirm the effectiveness of the solution and to detect any new issues. This systematic, data-driven, and risk-aware approach ensures the best outcome for the system and the business. Question 17. The performance metrics show a consistent increase in query response times for critical reporting workloads over the past week, with no recent changes to the application code or data volume. Option A. Disable all logging for the database to reduce I/O overhead. Option B. Restart the DB2 instance during peak business hours to clear any potential transient issues. Option C. Analyze the explain plans for the most frequently executed reporting queries and investigate potential index inefficiencies or suboptimal join strategies. Option D. Immediately increase the size of the buffer pool for all table spaces to their maximum allowed value. Correct answer is C. Analyze the explain plans for the most frequently executed reporting queries and investigate potential index inefficiencies or suboptimal join strategies. Explanation. This scenario presents a common challenge for DB2 administrators, identifying and resolving performance bottlenecks without introducing new issues or violating operational best practices. The professional challenge lies in accurately diagnosing the root cause of the performance degradation from a broad set of potential factors, including inefficient query design, suboptimal database configuration, or inadequate system resources. A hasty or misinformed decision can lead to further performance degradation, data corruption, or service disruption, all of which have significant business implications and could potentially lead to regulatory scrutiny if service-level agreements, SLAs, are breached. The correct approach involves a systematic and data-driven investigation. This means leveraging DB2 built-in monitoring tools and diagnostic utilities to pinpoint the exact source of the performance issue. For instance, examining the DB2 diagnostic log, snapshot monitors, and the explain plan for problematic queries provides concrete evidence. Implementing changes based on this evidence, such as optimizing specific SQL statements or adjusting relevant database configuration parameters, e.g., buffer pool sizes, sort heap sizes, represents best professional practice. This methodical approach ensures that interventions are targeted, effective, and minimize risk. Adherence to established DB2 performance tuning methodologies and documentation, which are implicitly guided by general IT best practices for system stability and availability, is crucial. An incorrect approach would be to randomly adjust configuration parameters without understanding their impact or without correlating them to the observed performance metrics. This is professionally unacceptable because it is speculative and increases the risk of unintended consequences. For example, arbitrarily increasing memory allocations without identifying a memory-bound process could lead to excessive paging and further performance degradation. Another incorrect approach is to focus solely on hardware upgrades without first exhausting software-level optimizations. This is a costly and often ineffective solution if the underlying issue is with query efficiency or database design. Ethically, Administrators have a responsibility to manage resources efficiently and to implement solutions that are well justified by data, rather than resorting to expensive, unproven fixes. Failing to document the diagnostic steps and the rationale behind any implemented changes also represents a failure in professional accountability and auditability. The professional decision-making process for such situations should involve 1. Clearly defining the observed problem and its impact. 2. Gathering all relevant performance data using appropriate DB2 tools. 3. Analyzing the data to identify potential root causes. 4. Formulating hypotheses about the most likely causes. 5. Prioritizing potential solutions based on impact, risk, and feasibility. 6. Implementing the chosen solution in a controlled manner, ideally in a test environment first if possible, or with careful monitoring in production. 7. Verifying the effectiveness of the solution and documenting all steps taken. Question 18. The audit findings indicate a consistent degradation in query response times across several critical applications, suggesting a potential process optimization issue within the DB2 one database for Linux, UNIX, and Windows. What is the most appropriate initial step to diagnose and address this performance concern? Option A. Implement a system-wide database parameter tuning exercise without specific diagnostic data. Option B. Analyze query execution plans using the DB2 explain facility and review buffer pool hit ratios and lock contention metrics. Option C. Advise application developers to rewrite all queries to reduce their complexity. Option D. Immediately increase the allocated CPU and memory resources for the DB2 database server. Correct answer is B. Analyze query execution plans using the DB2 explain facility and review buffer pool hit ratios and lock contention metrics. Explanation. Scenario analysis. The audit findings highlight a potential performance bottleneck within the DB2 one database environment. The challenge lies in identifying the root cause of the performance degradation without disrupting ongoing operations or introducing new risks. A DBA must balance the need for thorough investigation with the imperative to maintain service availability and data integrity, all while adhering to established operational procedures and potentially internal service level agreements. The pressure to resolve the issue quickly can lead to hasty decisions, making a systematic and informed approach crucial. Correct approach analysis. The correct approach involves a methodical investigation using DB2 built-in diagnostic tools and performance monitoring features. This aligns with best professional practices for database administration, which emphasize data-driven decision-making and minimizing impact. Specifically, leveraging tools like the DB2 explain facility to analyze query execution plans, monitoring buffer pool hit ratios, and examining lock contention provides concrete evidence of performance issues. This approach is consistent with the general principles of IT service management and operational excellence, aiming to identify and resolve issues efficiently and effectively without introducing further instability. While no specific DB2 for Linux, UNIX, and Windows regulations are cited, the underlying principle of responsible system management and performance tuning is universally expected. Incorrect approaches analysis. One incorrect approach would be to immediately implement broad, unverified configuration changes across the entire database system. This is professionally unacceptable because it lacks a diagnostic basis, increases the risk of unintended consequences, and could exacerbate performance issues or cause system instability. It bypasses the due diligence required to understand the problem before attempting a solution. Another incorrect approach would be to focus solely on hardware resource allocation, e.g., increasing CPU or memory, without first analyzing the database's internal behavior. This is a costly and often ineffective solution if the bottleneck is within the database's configuration or query design. It represents a failure to apply a systematic troubleshooting methodology and can lead to wasted resources. A third incorrect approach would be to ignore the audit findings and assume the performance issues are transient or user-related without any investigation. This is professionally negligent and ethically questionable, as it fails to address a reported problem that could impact business operations. It demonstrates a lack of accountability and commitment to system health. Professional reasoning. When faced with performance audit findings, a DBA should adopt a structured problem-solving framework. This typically involves 1. understanding the reported problem and its impact. 2. Gathering relevant data using diagnostic tools. 3. Analyzing the data to identify the root cause. 4. Developing and testing potential solutions in a controlled environment. 5. Implementing the chosen solution with appropriate monitoring. 6. Documenting the process and outcome. This systematic approach ensures that solutions are targeted, effective, and minimize risk, reflecting professional responsibility and adherence to sound IT practices. Question 19. Regulatory review indicates a need to enhance data access controls for sensitive customer information stored within DB2 databases managed on Linux, UNIX, and Windows platforms. The database administration team frequently requires access to this data for performance tuning and troubleshooting. What is the most compliant and secure approach for granting and managing such access? Option A. Grant all DBAs standing broad access privileges to all sensitive customer data to expedite troubleshooting and performance tuning efforts. Option B. Implement a formal request and approval process for all access to sensitive data, requiring detailed justification and authorization from a designated data owner. All access must be logged and audited using secure encrypted channels. Option C. Perform direct, undocumented access to sensitive data when troubleshooting issues, with the understanding that this access is temporary and for operational purposes only. Option D. Rely on the inherent trust within the DBA team, allowing them to access sensitive data as needed without formal requests or logging, assuming they will act responsibly. The correct answer is B. Implement a formal request and approval process for all access to sensitive data, requiring detailed justification and authorization from a designated data owner. All access must be logged and audited using secure encrypted channels. Explanation. Scenario analysis. This scenario presents a professional challenge for a DB2 DBA concerning data privacy and compliance within the context of Linux, UNIX, and Windows environments. The core difficulty lies in balancing the operational need for data access for troubleshooting and performance tuning with the stringent requirements of data protection regulations. The DBA must navigate potential conflicts between internal operational demands and external legal mandates, ensuring that any data access is both necessary and appropriately secured. The challenge is amplified by the distributed nature of Linux, Unix, and Windows systems, which can have varying security configurations and auditing capabilities, making comprehensive oversight critical. Correct approach analysis. The correct approach emphasizes a proactive, policy-driven, and auditable method for data access. This aligns with best professional practices by ensuring that data access is not ad hoc, but is governed by established procedures that prioritize data security and regulatory compliance. By requiring documented requests, approval from authorized personnel, and the use of secure, audited access methods, the DBA establishes a clear chain of accountability. This approach directly supports regulatory frameworks by demonstrating due diligence in protecting sensitive data, minimizing the risk of unauthorized access or breaches, and providing a verifiable audit trail in case of an incident or regulatory inquiry. This method upholds the principle of least privilege and ensures that data is only accessed when absolutely necessary and by authorized individuals. Incorrect approach is analysis. An approach that involves direct, undocumented access to sensitive data for troubleshooting, even with good intentions, represents a significant regulatory and ethical failure. It bypasses established security protocols and creates a blind spot in the audit trail, making it impossible to track who accessed what data and when. This directly violates data protection principles and increases the risk of data misuse or exposure, potentially leading to severe penalties under relevant data privacy laws. Another incorrect approach, which is to grant broad, standing access privileges to all DBA team members for all sensitive data, is also a failure. This violates the principle of least privilege, a fundamental tenet of information security and data protection. It unnecessarily exposes sensitive data to a wider group than required, increasing the attack surface and the likelihood of accidental or intentional data breaches. Such a practice would be viewed unfavorably by regulators, as it demonstrates a lack of granular control and a disregard for data minimization principles. Finally, an approach that relies solely on the hope that team members will do the right thing, without any formal process or oversight, is ethically and regulatorily unsound. It abdicates responsibility for establishing and enforcing robust data security practices. This lack of a defined process creates ambiguity, increases the risk of non-compliance, and leaves the organization vulnerable to breaches and regulatory sanctions. It fails to demonstrate a commitment to data protection and can be interpreted as negligence. Professional reasoning. Professionals in this role should adopt a decision-making framework that prioritizes a risk-based approach to data access. This involves understanding the sensitivity of the data, the purpose of the access, and the potential impact of any unauthorized disclosure or modification. Establishing clear, documented policies and procedures for data access, including request, approval, and auditing mechanisms, is paramount. Regular training on data privacy regulations and security best practices for all personnel involved in data management is also crucial. In situations requiring access to sensitive data, the DBA should always seek the least intrusive and most secure method, ensuring that all actions are logged and auditable. This proactive and controlled approach not only mitigates risk, but also builds trust with stakeholders and demonstrates a commitment to responsible data stewardship. Question 20. Governance review demonstrates that the DB2 one instance on Linux supporting a critical financial reporting application has a known security vulnerability due to an outdated patch level. The security team has provided an urgent recommendation to apply the latest security fix. As the DBA, what is the most responsible course of action to ensure both system security and operational continuity? Option A. Immediately apply the security patch to the production DB2 one instance during a low activity period to address the vulnerability as quickly as possible. Option B. Implement a temporary network access control list, ACL, to restrict access to the DB2 instance from external sources as a workaround while deferring the patch application. Option C. Escalate the issue to senior management and request a temporary shutdown of the financial reporting application until a permanent solution can be identified and tested. Option D. Develop a comprehensive test plan to apply the patch in a non-production environment that closely mirrors production, followed by a scheduled deployment to production with a rollback strategy. Correct answer is A. Immediately apply the security patch to the production DB2 one instance during a low activity period to address the vulnerability as quickly as possible. Explanation. Scenario analysis. This scenario presents a common challenge in database administration where a critical system component, the DB2 one instance on Linux, is identified as having a potential security vulnerability due to outdated patch levels. The challenge lies in balancing the immediate need for security remediation with the operational risks associated with applying patches to a production environment. Stakeholders, including business users, security officers, and IT management, will have differing priorities and risk tolerances. The DBA must navigate these competing interests while ensuring compliance with internal security policies and potentially external regulatory requirements. Though none are explicitly stated as US-specific for this exam, the principle of due diligence applies. The pressure to resolve the vulnerability quickly, coupled with the potential for service disruption, makes this a high-stakes decision. Correct approach analysis. The correct approach involves a structured, risk-mitigated process for applying the necessary security patches. This begins with thorough testing in a non-production environment that closely mirrors the production setup. This testing phase is crucial for identifying any compatibility issues, performance regression, or unexpected behavior that could impact the live system. Once testing is successful, a carefully planned deployment strategy is executed, typically during a scheduled maintenance window to minimize user impact. This includes having a rollback plan in place in case of unforeseen problems. This approach represents best professional practice because it prioritizes system stability and data integrity while addressing the security risk. It demonstrates due diligence and a commitment to maintaining a secure and reliable database environment, aligning with general IT governance principles of risk management and change control. Incorrect approaches analysis. Applying patches directly to the production environment without prior testing is a significant regulatory and ethical failure. It violates the principle of change management and introduces an unacceptable level of risk to the business operations. If the patch causes data corruption or system downtime, it could lead to financial losses, reputational damage, and potential noncompliance with any service-level agreements or industry best practices. Ignoring the vulnerability due to fear of disruption is also a failure. This demonstrates a lack of proactive security management and a disregard for potential threats. Security vulnerabilities, if exploited, can lead to data breaches, unauthorized access, and severe compliance violations. The DBA has a professional responsibility to address known security risks. Implementing a workaround without applying the actual patch, unless it is a documented and approved temporary measure with a clear plan for permanent remediation, is also problematic. Workarounds may not fully address the root cause of the vulnerability and could introduce their own complexities or security gaps, can also lead to a false sense of security. Professional reasoning. Professionals should approach such situations by first understanding the nature and severity of the vulnerability. This involves consulting official vendor advisories and internal security assessments. Next, they should evaluate the potential impact of the vulnerability on the business and the potential impact of applying a fix. A risk assessment matrix can be a valuable tool here. The core of the decision-making process should be a robust change management framework that includes thorough testing, impact analysis, and rollback planning. Communication with all relevant stakeholders throughout the process is paramount, ensuring transparency and managing expectations. This systematic approach ensures that security is addressed responsibly, minimizing operational disruption and maintaining system integrity.